Hello everyone! This video is going to be a little review of a lot of the topics we've done in the first 2 trimesters and a way to help you study for your exam. I'm hoping that between this video and the topics list and the other video that you watch, you will pick up on so many hints so that the exam will be a positive experience for all of you. That's really the goal here. There are a lot of hints. I'm not going to say the exam is easy. There's so much on it. It's challenging for sure, but there are a lot of hints here. So hopefully you'll pick up on them, and please ask any questions so that you're able to get them resolved, because these topics are going to be on your exam. So just make sure that you understand them all well. To get started, let's go back to something we haven't done for a good while, these limit problems. So this is a problem we've been seeing since the beginning of the year, and we've now picked up 3 different methods to solve this type of problem. I'm going to talk about all 3 of them in this slide. I'm asking you to do at least 2 methods so that you're able to review it and pick and choose when you go to take your exam. So the first one that I'll do is something that you knew before you even started this class. So that was multiplying by the conjugate. This is maybe the easiest quote-unquote rule to apply, but I think it's the longest method. So, you do what you like. So if we multiply by the conjugate, the purpose of that is so the outer and the inner, when you FOIL, will cancel out so that you're just left with, in this case, 16 plus x. The outer and the inner, of course, cancel out, and then you have minus 16. And then on the bottom, remember, never distribute. Just leave this because something's going to magically cross out in all of these question types. So on the top, the 16 minus 16, so you just have the x left. And so those will cancel out. And now that I can plug it in, I don't need to write a limit anymore. So I just have a 1 on the top over root 16 plus 0 plus 4, and that's 4 plus 4, 1/8 as my final answer. Another method could be to see if you could express this as a derivative. So let's see if this one actually works. And I'm tempted to use it because I see a limit as x approaches 0. And I remember that my definition for f prime of x is the limit as h approaches 0 of f of a plus h minus f of a all over h. And so this looks very similar in form, and I want to check if it is the right form. So if it is the right form, then my f of a plus h, my a would be 16. And what am I doing to my a plus h? I am square rooting it. So my f of x would be just root x. Now, to see if it's of the right form, we would have to check out that this is actually f of a. Here's our check. F of a in this case is root 16, right? Which is 4. So yes, it checks out. Yes, it is of this form. This is my f of a plus h minus f of a all over h. Because of that, I know this is a definition of f prime of a, in this case 16. If f of x is root x, what is f prime of 16? F of x is x to the 1/2, would mean that f prime of x is 1/2 x to the negative 1/2, and that would mean that f prime of 16 is 1/2 16 to the negative 1/2, and that is just 1 over root 16, which is 4. 2 times 4 again is 1/8. Now I said there's actually 3 methods, and I am going to go ahead and do one more, even though I'm running out of space here. This might be a L'Hopital problem. Let's see if it is. The limit as x approaches 0, if I put in the 0 on the top, I get root 16 minus 4, which is 0. In the denominator, that is just 0. So since this is of the form 0 over 0, we can use L'Hopital. And remember, L'Hopital is that you take the derivative of the top over the derivative of the bottom. So you're not taking a derivative, but this is L'Hopital's rule. Now the derivative of the top is a chain. It's 1/2 16 plus x to the negative 1/2 times just 1, because the derivative of 16 plus x is 0 plus 1. And then the derivative of 4 is 0. Just write that over. The derivative of x is just 1. So that's really nice, because now if I put in my 0, I get 1/2 16 plus 0, which is just 16, to the negative 1/2 times 1 is just itself, minus 0 doesn't do anything, all over 1, which isn't going to do anything. So that's the same answer I just got, right? That is 1 over 2 times 4, which is, again, 1/8. So you pick your method that you like best. Now this problem, I'd like you to try this one and see what two methods you choose to use. Can you use L'Hopital? You would get root 16 minus 4, which is 0 over 0. So it is of the form 0 over 0, therefore can use L'Hopital. That would be one method. I'm going to see if I can use my f prime rule. In this one, this looks like f prime of x. This is the limit as x approaches 10, so it's not approaching 0. So I think it might be the limit as x approaches a of f of x minus f of a all over x minus a. Let's see if it is. Let's see if that checks out. If it was, then our a would be 10, and our f of x would be root x plus 6. But to confirm, we need to make sure that this is our f of a. If a is 10 and f of x is that, then f of 10 is root 16, which is 4. So that checks out, and I can actually use this formula. If my f of x is root x plus 6, then what is my f prime of x? That would be 1/2 x plus 6 to the negative 1/2, and then I have to chain it times 1. So that would mean that my f prime of a, which is 10, is 1/2 16 to the negative 1/2, 1 over 2 root 16, which is just coincidentally the same answer, 1/8 here. And then, of course, I can, in this one, also use my multiply by the conjugate. So I'm going to use that as my second method. The goal is to get rid of the root in the numerator. So you know that's going to be the conjugate you multiply by. So when you FOIL the top, the outer and the inner are going to cancel out. So you're just left with the limit as x approaches 10 of that x plus 6 minus 4 times 4 is 16 all over. And remember what I said, do not FOIL this bottom. Don't ever multiply the bottom out, because something magical always happens on AP problems. Yeah, no, if you're doing it right. So on the top, you have that x minus 10. Are you seeing the magic yet? There's my magical. The x minus 10 and the x minus 10 are going to cancel out. So I have just a 1 on the numerator. And then if I put in a 10, I have root 16 plus 4, which is 4 plus 4, or 8. And you can also use L'Hopital. You can prove that one to yourself if you'd like extra practice. You should get 1/8, obviously. So go ahead and fill out this slide. See if you can make a connection between the various methods and what it reinforces. I would like you to do this slide on your own. Okay, now this problem is going to look very similar to the one that we just did, but there is a bit of a difference because this one's a limit as x approaches 0. You might be tempted, okay, I'm going to do a couple of wrong things first. You might be tempted to say, oh, this looks like a formula, f prime of x. We just have done all of these. The limit as x approaches 0 of f of a plus h minus f of a all over h. No, this is not of the right form. First of all, there's not just an x in the bottom, and if my a was 10 and my function was root x, then root 10, that doesn't check out. Remember, you need to do your f of a check. So that's not of the right form. I cannot use this in this example. And then you might be thinking L'Hopital. But if I put in a 0, what do I get? I get root 10 minus 4 over 0 minus 6. Not of form 0 over 0. In fact, I could just plug it in because I don't even have a 0 over 0, which is actually my point in this problem. And you also might be tempted to multiply by the conjugate, because we do that so many times when we see a root, but that's not necessary and just all too much work, and you might not finish if you do things like that. Always try and plug it in first. If you can, then you just go with it. So the only time we need to do something else is when we get 0 over 0, but in this case, I would have had root 10 minus 4 over negative 6. Final answer, and I'm done. Nothing else needed. Now, when you're doing the limit as x approaches infinity, I don't want you to forget those types of problems. We divide through by the highest power of x in the denominator. In this case, it is simply x. Divide through by x. But in the numerator, remember that x is of degree 1. So if it's under the root sign, to get degree 1, I want to be dividing by root x squared, okay? Because that's the same degree as x. So I need to divide through by root x squared. under the radical, but not under the radical just by x. I'm going to write that out a bit bigger just so you can see. I crammed it a little bit there. So that was my original problem. What I did was I divided by just x everywhere. But because this one's under the radical I need to divide by root x squared, because root x squared is power 1. So that's why I'm doing x squared here, but just x here, because this is not under the radical. And so now I'm left with this goes off to 0, this goes off to 0, this goes off to 0. So 0 over 1 minus 0. 1. 0 over 1 is 0. If it was 0 over 0, I have to do something else. But 0 is just my answer here. Now here's another limit as x approaches infinity. So I'm going to just rewrite this really quickly. And you're like, okay, I divide by the highest power of x in the denominator. There is no denominator. I can't just randomly multiply or divide. But what I am allowed to do is, divide by x on the numerator and the denominator, because that's like multiplying by 1. If I do the same thing on the top and the bottom. Let's create a bottom since 1 isn't here. So let's multiply by the conjugate, but in the form of 1. And so now I have the limit as x approaches infinity, x squared plus 5 minus 4 all over root x squared plus 5 plus 2. So now divide through by the highest power of x in the denominator. Again, wherever I see the radical, that is just degree 1. So under the radical, I'm going to be dividing by that x squared. But when it's not under the radical, that is just an x, because it is just first degree. Root x squared is first degree. Here, there's no radical in the numerator. Just divide by x, divide by x, divide by x. I could have simplified that as 1. But those are all going to go off to 0. So I have x squared divided by x is x, right? So I have an x on the top, 0, 0, all over root 1 plus 0 plus 0. The limit as x approaches infinity is infinity over, this is just 1 in the denominator, or infinity. Now, let's practice some limits, which we haven't done in a while. This is the curve h of x. The limit as x approaches -1 from the left. So as we go to -1 is here. From the left, we are going to a y value of 1 in B. -1 from the right, we're going to a y value of -2. Because the left limit and the right limit are different, the limit does not exist at -1. However, when they ask you h of -1, it is defined at -1. At -1, our value is 1. So this is one of those that was left-hand continuous. I don't care that you know that. You do not need to know that. But it is defined at 1. It's just that the left and the right limits are not the same. Now let's look at 3. As x approaches 3 from the left, as we go to 3, an x value of 3, I'm going to highlight that. So we're looking at 3 now. From the left, we're going to a y value of 2. 3 from the right, we're going to a y value of 3. Since the left and the right are different, the limit does not exist. And h of 3, where is it defined at 3? It is defined at 2. Now on the exam, I might just ask you this part of the question. And in order to get that part, you need to look at the left and the right. Don't get tricked. Remember, these two things are asking different questions. The limit is not h of 3 because it's not continuous in this case. Here's a little sketching practice. F of 0 is 3 is the first thing. So f of 0 is 3. That's a closed circle. Got that. The limit as x approaches 0 from the left is 4. So x value is 0, y value of 4. And that's on the left-hand side. So that's a left tail. Okay, just let it hang out. And then the right tail is going to be at 2 because that's the right. 0, 2 is the point. Remember, this is x, this is y. 0, 2, right. The limit as x approaches -infinity is -infinity. That means all the way on the left, the y value is teeny tiny. All the way on the left, teeny tiny. The limit as x approaches 4 from the left is -infinity. So at an x value of 4, we're going off to a y value of -infinity, and that was from the left. From the right, we're going off to +infinity. So from the right, we're going off to positive infinity. And then the limit as x approaches infinity is 3. So that means we trail off on the right-hand side, because that's as x approaches infinity, the right-hand side, we trail off to 3. I don't know from the top or the bottom, but the fact that I want to hit this arrow, right, because that's the closest one, I know I want to pick up the top one. So that's how I know I want to pick up the top one. And then we can just get rid of this bottom one. Then you need to just play a game of connect the dots. So this tail has to hit this one. Just make it as easy as you can. And this has to hit this tail, and that's it. Great graph. There are a lot of different variations. Just make sure you're drawing a function. To prove continuity, remember that you need 3 things. The limit from the left, and this is at -1 is our problem spot in this one. So the limit as x approaches -1 from the left, the limit as x approaches -1 from the right, and the function value at that point. We're going to do all 3. -1 from the left, this is from the left and at that point, and we only use this one from the right. From the left, we're going to be using this one, a times -1 squared minus 3. That's a minus 3. From the right, we use the top one, a times -1 plus 5. That's -a plus 5. And then the function value at that point, we use the same one, but we do need to rewrite it just to show that we thought about it, considered it, and we did something with it. Now to make it continuous, all 3 things have to equal each other. These 2 are already equal, so just this has to equal this. A minus 3 equals -a plus 5. 2a equals 8. A equals 4. And that's all you have to do. Now this function, what do you know about it? Is it continuous everywhere? Yes, because I can draw it the whole time without picking up my pencil. So it is continuous everywhere. Continuous everywhere except at x equals 2. No, it was continuous everywhere. Is it continuous and differentiable? It fails differentiability at 2. That's what it fails, because there is a corner right there, or a cusp. So it is not differentiable. The derivative does not exist at x equals 2. Continuous everywhere is my answer in this one. Given this graph, shade where f prime is greater than 0. Remember, f prime greater than 0 means f increasing. So where is f increasing? F is increasing from here to here and from here to here. That's all I need to do for that one. Shade where f double prime is greater than 0. Remember, f double prime greater than 0 means f is concave up, or happy. So where is my function happy? It looks like right around here is my inflection point. Going from unhappy, it turns up to happy around there and forever on. So that is where it is concave up. Where is f of x greater than 0? F of x greater than 0 means that the function itself is greater than 0. The y value is greater than 0. So the y values are positive there. Okay? That's just saying, where is y positive? Given the graph, place a dot on all the points where f prime equals 0. Remember, f prime equals 0 means that the tangent line flattens out. So, it was positive, and then it goes to 0 right around there. And then it's negative, 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 and then it goes to 0 right around there. So there and there. And those are also called my critical values. So I just want to take it back to a quiz that we did a long time ago, all the way first one of the year, where we found the instantaneous velocity by looking at the slopes when the numbers were getting closer and closer and closer together. And it was a very time-consuming process, and now we know a much better way. If we are given the position function, this is the position, a ball is thrown into the air. This is the height after t seconds, so that's our position. Y equals 30t minus 16t squared, and it asks us for the instantaneous velocity. We now know that the velocity is the derivative of position, and if y is position, then it's just y prime. It is just 30 minus 32t. If they're asking us at t equals 2, I would do y prime of 2, which is 30 minus 32 times 2, 30 minus 64, which is negative 34. Our units are going to be feet per second. Don't forget units. They will be worth partial credit for every single problem that involves units. You only need it if you see units in your problem. So I'd like you to also do this slide. Think about what the original solution was saying and what your new solution is saying and how they are connected. And don't forget what the derivative means, right? We talked about the limit as h approaches 0 of f of a plus h minus f of a all over h, that being the definition of f prime of a, right? What does that mean to you? Talk to me about it in this slide. Now, on this question, y equals x to the fourth has an inflection point at 0, 0. Is that true or is that false? Well, an inflection point, a lot of people say, is where f double prime equals 0. And that isn't quite true. It is sometimes true. An inflection point is where f double prime changes sign. And so I've purposely chosen this problem to prove a point to you. Ready for it? Y equals x to the fourth. Y prime equals 4x cubed. Y double prime equals 12x squared. Y double prime, what goes on the number line? Y double prime equals 0 when x equals 0, right? 12x squared equals 0 only when x is 0. But if I put in a negative number, I get a positive. If I put in a positive number, I get a positive. It doesn't change sign. It goes from positive to positive, which means that it goes from f being concave up to f being concave up. There is no change in concavity. A change in concavity is another way to say that f double prime changes sign, right? Because f double prime positive meant that f was concave up. F double prime negative meant that f is concave down. And so in this one, we have no inflection point, and our answer is false, even though f double prime does equal 0 at x equals 0. So don't get tricked. In order to show an inflection point, we must have a change in sign. Just like in order to have a max, we must have a change in sign. Not just f prime equals 0, f prime changes sign for a max or min. For an inflection point, not just f double prime equals 0, but f double prime changes sign. Okay, I think I've made my point. On this one, they ask you to just find the inflection point. So let's go ahead and do that. We're going to find f prime first. 4x cubed minus 12x plus 8. F double prime then is 12x squared minus 12. I can go ahead and take out a 12. That will make it easier. Then I can factor. So on my number line, I'm going to have a -1 and a 1. And since this is a parabola that's opening up, I pretty much know that it's going to be positive, negative, positive. But if you need to prove that to yourself, go for it. You can plug in values. If you plugged in a 0, you would get -12. If you plugged in like a -2, you would get 12 times a negative, which would be a positive. So anyway, inflection points are where f double prime changes sign. And so that's going to be at -1 and at 1. But inflection points are points, and they're points on the curve. Whenever you have points, they're on the curve. So you have to plug it back into the original function. F of -1 is going to be -1 to the fourth is 1, minus 6 times -1 squared is -6, plus 8 times -1 is -8, plus 10. And then we have 11, minus 8 is 3, minus 6 is -3. And then if we put in a 1, we have 1 minus 6 plus 8 plus 10. And so we have 13. So my inflection points are f of -1 is -3 and f of 1 is 13, but you can just leave it written just like that. That's full credit. Great. If y equals 10 is a horizontal asymptote, then, sorry, I thought these were going to come out as formulas. Obviously they did not. But if it's a horizontal asymptote, horizontal is this way. So that means what's happening on all the way on the left and all the way on the right, which is the limit as x approaches infinity, should be going to 10, or negative infinity is 10. So it's something about the limit as x approaches infinity or negative infinity. If the limit as x approaches 10 is infinity, that means at x equals 10, we go off to infinity. That would be a vertical type thing, right? As x value is 10, we go off to a y being infinity. This is the x stuff, and horizontal is the x stuff. All right, continuing on, this question is asking about some asymptotes and discontinuities, removable and non-removable. So let's go ahead and factor this guy first. So on the top, that's x plus 2, x minus 2, the difference of two squares. On the bottom, I can actually just take out an x squared, so I get x minus 2 really nicely there. Then the x minus 2's are going to cancel out. So I'm going to do part C first, because whatever cancels out, remember, is our removable discontinuity. at x equals 2 because you set x minus 2 equal to 0 and you get x equals 2. And then the one that's left is a non-removable at x equals 0 because x squared equals 0, x equals 0. Now vertical asymptotes are the same thing. It's wherever the denominator equals 0 after you've simplified. People all the time do that incorrectly. They just set the denominator equal to 0. Don't forget that you have to simplify first and then whatever's left set equal to 0. So that's just x squared equals 0, x equals 0. For part B, horizontal asymptotes, that is, remember the limit as x approaches infinity. That's what's going on the left and right of the graph. You might know the answer to this without doing any work, but I'm just going to explain it out. You divide through by the highest power of x in the denominator, which is x cubed in this one. We only divide through by the highest power of x in the denominator when we're doing a limit as x approaches infinity type problem. Don't forget that, okay? Now, we have 0 minus 0 on the top, and on the bottom we have 1 minus 0, which is 1. So that's 0. But our final answer is not just 0. A horizontal asymptote is y equals 0. You do need to say x equals for a vertical and y equals for a horizontal. And then here is my answer to part C. Moving right along, some derivatives. The derivative of tangent squared of 2x. I'm going to just rewrite this as tangent of 2x squared. Remember, whenever you're doing trig stuff, you're doing cosine squared, sine squared, write it like this so that you can see that it's a chain rule problem. And this is actually a double chain because that's the first one. And then we go inside of that. The first thing we're going to be doing is a derivative of that box squared, which is 2 box times, then we're going to take the derivative of the box. So what is in that box? Tan 2x. And then what's the derivative of tan 2x? Well, the derivative of tan x is secant squared. Look on the topics list. I tell you which formulas you need to memorize. Any of them on the topics list you need to memorize. If it's not on the topic list, it is not going to be on your exam. So the derivative of tan of 2x, secant squared of 2x. But of course we had this as the baby, so we need to chain that, and we have times 2. So that's my final answer, and I can just leave it like that. That's great. Just no simplifying necessary. Leave it. Now this one, I wanted you to see this versus this. If I do the derivative of f of x cubed, then I'm doing box cubed, and the derivative of box cubed is 3 box squared times the derivative of the box. And what was in that box? F of x. So I have 3 f of x, that quantity, squared times the derivative of f of x is f prime of x. So that's my answer there. I'll just rewrite it. Versus in this one, my baby is the x cubed. I'm doing f of x cubed. The derivative of f of box is f prime of box times the derivative of the box. So leave the baby inside. F prime of x cubed times the derivative of x cubed is 3x squared. So see the difference between those two? This is very popular. You'll see this on the AP exam with the table of values and you plug in a value. Very, very popular type question. So make sure you take a good look at that and understand the difference between those two, and you would be able to do it on your own. Okay, on this one threw everybody at the beginning, but hopefully it feels good now. This is e to the, that's going to be your baby. So the derivative of e to the box is e to the box times the derivative of the box. So leave the baby inside. And then the derivative of x cosine x requires a product rule. So the derivative of x cosine x is 1 times cosine x, derivative of the first times the second, plus the first times the derivative of the second. And the derivative of cosine is a bad sign, negative sign. So you can leave your answer just like that, or you could rewrite it. I really don't care that you rewrite it. Just as happy with you leaving it at this step right up there. On this question, when we want to differentiate, we have ln of baby. Remember that the derivative of ln is 1 over x. And so the derivative of ln box is 1 over box times the derivative of the box. So leave that baby inside, okay? 1 over x. And the derivative of sine times cosine, again, product rule, the derivative of sine, cosine times cosine, plus sine x first times the derivative of the second. And the derivative of cosine is negative sine. And so that's my answer, 1 over sine x cosine x. And then I have cosine squared minus sine squared. And if you're tempted to say that's 1, no, it's not. Cosine squared plus sine squared is 1. So don't make that mistake. Just leave it like that. Don't simplify and make a mistake. There we go. That's good for me. Find all intervals where f is decreasing given this is y prime. I was very nice to you on this one. I gave you y prime. We know f is decreasing when f prime is less than 0. So we just need to see where this is less than 0. But you can't just set this less than 0 because you need to remember that a negative times a negative is a positive. So you need to consider that. And don't forget, let me just start with critical values because that might come up on your exam. Critical values, everybody always remembers y prime equals 0, but then they easily forget y prime does not exist. And this case in point is one where it matters. Let's get a common denominator because that's the only way. Remember, this is already y prime, so I don't need to take a derivative. I was nice to you. But you need to get the denominator, a common denominator, so you can see where y prime does not exist. So the common denominator here is just x. In order to get an x on the bottom here, I would need to multiply by an x on the top. So I would get x cubed over x minus 8. So my critical values are where the numerator equals 0, x cubed minus 8 equals 0, x cubed equals 8, x equals 2, or where y prime does not exist, which is at x equals 0. So I need to put those all on my number line, 0 and 2. And now I need to look positive and negative. So if I have a negative number, then on the numerator I would have negative minus 8. So that would be negative in the numerator over in the denominator negative. Aha, that's actually positive. And then if I put in a 1, I would have 1 minus 8. That would be negative over 1 is a positive number. That would be negative. And then if I put in a 3, that would be positive over positive, which is positive. So f is decreasing when f prime is less than 0, and that happens from 0 to 2 in this problem. But you see, if I didn't get that common denominator, I would have lost an answer. I would have gotten it all wrong. So make sure you're considering both where it equals 0 and where y prime does not exist. Find the equation of the normal line. Remember, the normal line is the same as the perpendicular, so we want to take the negative reciprocal of the slope at the point. So first of all, what is y prime? Y prime is 3x squared plus, that's the baby, e to the 2x times 2. Don't forget to chain it. Then we're going to find at the point. Because remember, if you're saying, oh, that's my slope. No, our slope doesn't have x's in it. Our slope is a number. We want the slope at the point 0. We're finding the equation of the normal line at x equals 0. So put in a 0 and we get 3 times 0 plus e to the 0 times 2. E to the 0 is 1, so this is 2. So the slope of the normal line is negative 1/2. Now what's our point? Our point is y of 0. So you put 0 into the original equation. That would be 0 plus e to the 0, which is 1. So the equation of our line is y minus y1 equals the slope times x minus x1. Y equals negative 1/2 x plus 1 is the equation of our normal line. Now, when we want to find the absolute extrema on an interval, that's when we do the candidate test, or we test out all the potentials, which are the local maxes and mins, and we compare it to the endpoints. Remember, absolute, we need to remember when you see that, remember to check the endpoints, okay? Don't forget, check endpoints. You don't need to do a number line on this one because we're actually comparing values. So this is one that you don't need to prove it with a number line to say a max is, changing from f prime positive to negative, because you're just going to be looking for the absolute biggest number and the absolute smallest. I'll show you. Let me stop talking and let me start doing. F prime of x is 6x squared plus 6x minus 36. So I can factor out a 6, x squared plus x minus 6, and then I have x and x positive 3 and negative 2, my critical numbers are going to be x equals 2 and x equals negative 3. So I'm going to want to compare all the numbers, the endpoints and the critical numbers. And then I'm going to take the absolute biggest and the absolute smallest, and that's going to be my answer. Okay, so hopefully I didn't make any typos. F of negative 5 is 5, and let's look at f of 5 while we're here. So we have 5 and 145. And then let's look at negative 3. It's going to be 81, and then also at 2. 81 and negative 44. So our answer, this is our absolute max, and this is our absolute min. And that's all you need for justification for that type of problem. You don't need to do anything else except exactly what I've done there. Great, final answer. In this one, they want you to find y double prime, given this is y. Now notice this is a product rule. Hopefully that's the first thing that jumps out at you. So y prime equals, I'm going to call this my first and this my second. So the derivative of 5x squared is 10x times the second plus the first times the derivative of the second, and the derivative of e to the something is e to the something, and then we need to chain it. The derivative of 3x plus 2 is just 3. So let me just simplify this. Since I need to take another derivative, let's make it a little bit cleaner. That 5 times the 3 we can rewrite as 15x squared e to the 3x plus 2. Now the derivative of 10x e to the 3x plus 2 again is going to be a product rule. So let's take the second derivative. That's going to be my first. That's going to be my second. The derivative of 10x is 10 times the second plus the first times the derivative of the second, e to the 3x plus 2 times 3. We had just done that. So that's just this part. And then we're going to need to add, here's the first and here's the second for the second part. The derivative of 15x squared is 30x e to the 3x plus 2. Derivative of the first times the second plus the first times the derivative of the second, e to the 3x plus 2 times 3. Since I don't need to take any more derivatives, I'm going to just leave it just like that. And that is great for my final answer. I'm not going to simplify for this one. Obviously, you could take out an e to the 3x plus 2 and make it look a lot nicer, but that's great for this answer. If it was multiple choice, I might have to do that, but for now, I'm good to go. Equation of the tangent line at a point. So on this one, we haven't done implicit differentiation in a while, and that is going to be on your exam. So watch out for this one because this has x's and y's, and we can't just solve for y. So how we do this one, remember, is that every y has a baby inside of it. So the derivative of x cubed is simply 3x squared. But the derivative of 32y is 32 times y prime. Remember, implicit differentiation, every y has a baby inside or a y prime, a dy dx. Don't forget about that. Now, I don't want to FOIL this out because it's way long, so I'm going to do a chain rule. The derivative of box squared is 2 box to the first power times the derivative of that box is going to be the derivative of 5x squared is 10x. The derivative of y cubed is 3y squared, tack on the y prime, minus the derivative of x is 1. Now, you're going to be tempted to solve for y prime, but you don't need to. So please make a mental note to self, start somewhere, that we're finding the slope at the point 0, 2. So just plug in the point 0, 2 right away, especially because the x is 0. You're going to get rid of so much stuff. It's going to be so much nicer. So let's do that. 0 plus 32y prime. We don't know y prime. That's what we're trying to do. 2 times 5 times 0 is 0 plus 2 cubed is 8 minus 0. And that was just to the first power. 10 times 0 is 0 plus 3 times 2 squared is 3 times 4, which is 12, minus the 1 just stays. So I have 32y prime equals 2 times 8 is 16, and then I have 12y prime minus 1. I'm going to go ahead and divide both sides by 16, just make it simpler instead of making it bigger. 2y prime equals 12y prime minus 1, because the 16's canceled out. So then I'm going to scoot this over here. So I have 10y prime equals, and put that on that side, 1. Y prime equals 1/10. Have I answered the question? It says find the equation of the tangent line. So I have a slope, and do I have a point? ooh, I have a point. So y minus y1 equals the slope times x minus x1. In other words, y equals 1/10 x plus 2. There is my answer. You will see one of these types of questions on your exam, so make sure you practice this. We haven't done it in a while. In this problem, it says, first of all, this plane that flies with this velocity, it's given all in this table below. Find y prime of 20. So y prime of 20, they want to know the instantaneous velocity at 20. And we have data here to here and here to here. Remember, y prime of 20 is the slope at exactly 20. So the best way to do y prime of 20 and how you'll want to do it on the AP exam is find the slope between 15 and 20. I'm just going to write it as that. The slope between 15 and 20 is going to be y2 minus y1 over x2 minus x1, negative 2.5 over 5, and 25 over 5 is 5, so move the decimal point 1, negative 0.5. And then also look at the slope between 20 and 25 since I have data on both sides. And that's going to be y2 minus y1 all over x2 minus x1. Negative 2.1 over 5, which is negative 0.42. And then what you want to do is you want to average these to get v prime of 20. Because it's like, you're going on the left a little and on the right a little bit. And then the average will give you the best approximation. So that's going to be negative 0.46. And then our units are going to be miles per minute per minute. Negative 0.46 miles per minute or per minute squared. And so when it says interpret your results, that is just the instantaneous velocity at time 20 in miles per minute per minute. Now, if I want to find v prime of 17, I'm going to do that in blue. 17 there is like in between these two. So the best we can do is to just use 20 and 15. You see that? Because 17 is right in the middle here and I don't have like two sides. I don't have 17 represented at all. So the best I can do is use the two closest values. So in this case, I would just do the slope between 15 and 20, which I had already calculated right here, which was negative 0.5 miles per minute squared. So hopefully you see the difference there. At 20, I had data on both sides. At 17, it's smack in the middle, so I just use the closest points that I have and find the slope there. It's the best I can do. And now in part B, it says using right Riemann sums, approximate the value, I'm going to do this in purple, of 1/20th integral from 0 to 20 via t dt. Hopefully you recognize this as f average, right? F average is 1 over b minus a, integral from a to b of f of x dx. Isn't that what this is doing? But notice that it's only from 0 to 20 and my b minus a is 20. So this is only in the first 20 seconds. So this is going to be, it's going to represent my average velocity between 0 and 20 seconds. That was a little bit tricky, but the AP exam loves to be tricky like that. So I'm going to use the right Riemann sums because it tells me use right Riemann sums, and I'm only going from 0 to 20 in this case. So right. So I have 1 over 20. I'm using the right to approximate this integral part, okay? So that integral part is going to be width, which is 5, times the first height, which is 9.2. And actually the width is 5 everywhere, so I am going to factor it out in this one. So I have 9.2 plus 9.5 plus 7 plus 4.5. And I'm not going to even calculate that. I'm just going to leave it as that, but I do need units. And what are my units? If I'm thinking of units, the integral of via t dt, well, via t is miles per minute, and I'm taking the antiderivative, so I'm going from a rate to amount. So my integral from 0 to 20 of via t dt is just going to be measured in miles. But then the 1 over 20 represents the 1 over b minus a, which is the minutes. So that is going to be 1 over minutes as my calculation. And so if I have 1 over minute times miles, then my units are going to be miles per minute. So that's how you get the units. And you do need to be able to do this for the AP exam, and you should be able to do it for this exam. Just a very straightforward problem like this, you will see with units, and you have to be able to get the units, just like I did there. This problem you have seen 1,000 times, and I'm going to do it for the 1,001st time because it's important. Find all values of x on the open interval for which the function has a local maximum. So a local max is where f prime changes from positive to negative. This is the graph of f prime. They tell us it's going from positive to negative right there at x equals 4. That's my justification. That's all I need. Local min, f prime negative to positive, and that happens right here at x equals 6. Justification, all I need. Now determine the absolute maximum value. So I need the actual y value. They tell us f of 0 is 10. That's where I start. To get f from f prime, I have to take an antiderivative. So first of all, what do you think the absolute maximum value is going to be? Because this is the derivative. It means that our function's going up because it's positive, and then it's going up more, and then it's going down a little bit, but only going down 3, and then it's going up again, but it goes up more than it ever went down. So isn't the absolute maximum going to happen all the way at the very end? I think so, but you know what? I'm just going to prove this one for you. I know f of 0 is 10, and what are the other things that I would possibly consider? I'm not going to possibly consider the 1 because that's neither a min nor a max, a local min nor max, right? It just equals 0, but positive to positive, not a local min nor a max. And then right here we had a local max. We had identified this as a local max. So we should consider 4. And then this was a local min, so we're not going to consider that. But then we need the endpoint, which is f of 8. So we consider all the endpoints and all the locals. Now, what is f of 4? Well, we started at 10, and then we went up 2, and then we went up 6 more. Up 2, up 6 more, 18. Now, f of 8 could start at 0 again, but I'm going to be a little bit bold, and I'm going to just start at 4. We were at f of 4. And then we subtracted 3 and we added 7 more. So we have 18 minus 3 plus 7, which is 22. So my absolute maximum value is that f of 8 equals 22. And that is meaningful. You know how we were making up some numbers before? That was because they didn't tell us the actual area. So we just did relative. But this one, they tell us all the actual numbers. And so this is an actual answer. And they ask us the absolute maximum value. We need to give the y value in this one. And what people always forget is to start at 10 and they just, say, oh, it's 2 plus 6 minus 3 plus 7. No, you need to remember to add the 10 because it starts at 10. So you need to remember to start somewhere. And this one I started at f of 4 and then counted from there. So just remember starting point plus whatever the area under is, because literally what you're doing here is f of 4 is f of 0 plus the integral from 0 to 4 of f of x dx. And sorry, I meant f prime of x dx. The area under the f of x curve brings us back to the f curve. So don't forget to add that initial value. All right, let's do a quick ship problem. We're just going to do 2 related rates problems. You'll have one of them on the exam. At noon, a vessel is sailing due north at a uniform rate. So we have going north at 25 kilometers per hour. Another vessel 40 kilometers due north of the first. So they're initially 40 kilometers apart, is sailing due east at 20 kilometers per hour. At what rate is the distance between them changing? This ship is going closer, right? This is our point. So this one's going closer. So our dy dt is going to be negative because it's getting closer. The number's getting smaller. But this one, our dx dt, it's getting further. So that's going to be positive. And then it says at the end of an hour. So our scenario triangle after 1 hour, 20 kilometers per hour times 1 hour is just 20. And then 25 kilometers per hour in 1 hour is going to go 25 kilometers. But they were originally 40 away from each other. So to get the distance that he's away now, it's 40 minus 25. Don't forget that. This one's just going from 0. 0 plus 20 is 20. But this one started at 40 kilometers, going closer at 25 kilometers per hour. That's why it's negative. That's why I'm subtracting it. So 40 minus 25 is going to be 15. And if you can see, this is a 3, 4, 5 triangle because I have 3 times 5. I have 4 times 5. So this is going to be 5 times 5 or 25. If you don't see that, then apply the Pythagorean theorem. Now we know that x squared plus y squared equals z squared. So we have 2x dx dt plus 2y dy dt equals 2z dz dt, because this is a related rates problem, right? And every variable has a time in it in this one because we're moving x's and y's and z's. So everything has a baby in this one. I can cross out all of my 2's, and my x is going to be 20. Dx dt was 20, plus my y is going to be 15. My dy dt was negative 25, equals my z, which is 25. And I'm trying to find dz dt. So my final answer, and you better believe I'm not simplifying this one, is going to be 25 over 20 times 20 minus 15 times 25. And my units are going to be kilometers per hour. Boom. Great. That's my final answer. Optimize area. Ooh, I love this optimization type problem. A farmer has 600 feet of fencing to enclose 3 adjacent rectangular pens. What are the dimensions? So I have 3 adjacent rectangular pens. Why did I say that so quickly? 1, 2, 3. I'm going to call this y. I'm going to call this x, but don't forget here's a y, here's a y, here's a y, here's an x. If we have 600 feet of fencing, that means that we have x plus x, 2x, plus y plus y plus y plus y plus 4y equals 600. That's one piece of information. And we want to maximize the total area. The area of this is just our x times y. This is what we want to optimize. So this is going to be our helper. Remember, our helper helps us get our equation that we want to optimize in one variable. Why don't we just solve for y? We normally do that. 4y equals 600 minus 2x. Divide everything by 4. Y equals 150 minus 1/2 x. And so then get the area equation in terms of just x's. So instead of y, I'm going to sub in 150 minus 1/2 x. So simplify it first, 150x minus 1/2 x squared. And now to optimize, we want to take the derivative and set it equal to 0, because that's going to be how we find our potential maxes and mins. 150 minus 1/4 x, and that's all I have. And I should have said where a prime equals 0 or a prime does not exist, but in this case, we're never going to have a prime does not exist. So a prime equals 0. I'll just write it so you don't forget. You don't have to consider that case in this one. So we have 150 equals 1/4 x, multiply both sides by 4. We have x equals 600. And so our dimensions are going to be 600 feet by, what is y? Y, remember, was 150 minus 1/2 x. So 150 minus 300 means that clearly I made a mistake because that's negative. Oh, I just caught it. 1/2 times 2 is 1. So that should have just been minus x. Okay, I make mistakes too. So this is actually even easier now. I have 150 minus x equals 0. X equals 150. And so I have 150 feet by y equals 150 minus 1/2 times 150, which is 150 minus 75, or 75. And so those are my dimensions that are going to maximize my total area. Intermediate value theorem problem. To use the intermediate value theorem, f must be continuous, don't forget. So let's start with that. This is a continuous function, so we're good to go. And so intermediate value theorem is pretty much if one point is below x equals 0 in this case, because they want a root, which is x equals 0, and one is above, then we know if it's continuous, it must cross. That's what the intermediate value theorem is saying in very simplistic terms. So we are going to want to look at the endpoints that they give us, f of negative 2, and we're going to look at f of negative 1. So f of negative 2 is going to be 2 times negative 2 cubed is negative 8, plus negative 2 squared is 4, plus 2. So that's going to be negative 10. And then f of negative 1, that's going to be 2 times negative 1, plus negative 1 squared is 1, plus 2, which is going to be 1. So why don't we just pick it up right here? Since f is continuous, we can apply IVT, and we know that negative 10 is less than 0, which is less than f of negative 1, which is 1. You can either say f of negative 2 is less than 0, which is less than f of negative 1, or you can just put the values. It doesn't matter, but you just have to show one or the other. Because 0 is between negative 10 and negative 1, we know there is a c or some letter such that f of c equals 0, that's our goal, between -2 and -1. Now, this type of problem on your exam is likely going to be a multiple choice type question. So you don't need to worry too much about the wording here, but what's going to be important is that you understand that the root must occur, in this case, between, so let me redraw this one. I'm going to erase this and redraw it for this case. You know f of -2 is -10, and you know that f of -1 is +1. So you know that where does the root have to be? It has to strictly be between -2 and -1. And so that's really important for you to understand and know, that the root must be between -2 and -1. Now let's just do a mean value theorem to even things out. So is this one continuous and differentiable? We need that for MVT. It's not continuous and differentiable everywhere, but it is on the interval, because this is just not defined at x equals -2, but that's not on the interval. Now let's look at the derivative to make sure where it's differentiable. So in order to find the derivative, I can't get away from doing a quotient rule. Or I mean, you could do a product rule if you brought this up to the top, but that would be messier. You would need a chain also. So you may as well just do a quotient rule in this one. The derivative of the first times the second minus the first times the derivative of the second all over the second squared. So let's simplify that down. I have x plus 2 minus x all over x plus 2 squared. And so that is just 2 over x plus 2 squared. And so this one also has a problem spot at -2. So we know that it is on -1, 2, it's continuous and differentiable. So since f is continuous and differentiable on -1, 2, we can apply MVT. Very important first step. And then remember, MVT says that the slope equals the derivative somewhere. So we just found the derivative. Now let's find the slope. F of 2 minus f of -1 all over 2 minus a -1. So if I put in a 2, I'm going to have 2/4 minus, put in a -1, -1 over 1 all over 3. So I have 1/2 plus 1, that's 3/2. Divided by 3, so I'm going to multiply it by 1/3. So I have 1/2. So by MVT, let's make the slope equal to the derivative. 2 over x plus 2 squared equals 1/2. And then I could just get x plus 2 squared equals 4. Go ahead and take the square root of both sides. That's the easiest way to solve this problem, especially since the square root of 4 is plus or minus 2. So I have two answers. X equals -2 minus 2, which is -4, or x equals +2 minus 2, which is 0. But -4 is not in the interval, so I have to cross it out. And so my answer is just x equals 0. We're really almost at the end here. Let's do another one of these word problems. An ice sculpture is in the form of a sphere that melts away. The volume of the sphere is decreasing. So volume is decreasing. That's dv dt, the rate of decrease is -2 pi cubic meters per hour. So -2 pi. Decreasing is why it's negative. At what rate, in square meters per hour, is the surface area decreasing? So d surface area dt is what when the radius is 5. When the radius is 5. And they tell us all the formulas that we need to know here. So they tell us the surface area is 4 pi r squared, and the volume is 4/3 pi r cubed. Now, we want to know what the derivative of the surface area is with respect to time. So that's our goal. D surface area over dt is going to be 8 pi r, but don't forget, since this is a related rates problem, what's changing over time? The surface area is changing over time, but the radius is also changing over time of a sphere, right? So that radius has a baby in it. You can't forget about it. So they tell us that the radius is 5, but what is this dr dt? We don't know. So then we're like, oh, well, they gave us one more piece of information. Maybe we should use it. They gave us this information about dv dt, and they gave us our volume. So what is dv dt? dv dt is going to be 4/3 times 3 is 4 pi r squared. But again, that r is changing over time, so it has a baby in it. Our dv dt was -2 pi. They told us that. equals 4 pi, our radius is 5 squared. Oh, look, we're going to be able to solve for dr dt and then use it. Magic. Then the 2 pi divided by the 4 pi is going to give us a 2 on the bottom. And we also have this 5 squared on the bottom. And that's going to be our dr dt. In other words, dr dt is 1 over 2 times 25, which is 50. And I just realized I lost my negative because there was a negative there. So it's negative 1 over 50. So I'm going to replace that here. And then I can just simplify. So I have a 5 divided by a 50. I have a 10 on the bottom. So 8 pi over 10, and it's a negative, or negative 4 pi over 5. And this question said, at what rate is it decreasing? It's decreasing at a rate of 4 pi over 5. See, they already said decreasing, so that's why I don't need a negative in my answer. Decreasing at 4 pi over 5, and the units are square meters per hour in this one. Okay, our last problem before you get into a little bit of reflection is going to be a calculator problem. So I want you to find the area enclosed by these two regions, and I really, really want you to use just your calculator to do this problem. So I'm going to put the problem right here and my calculator right here. So in y1, I'm going to go ahead and put in that e equation. And then in y2, I'm going to put the square root equation. And then I'm going to graph. So this one obviously is my root 4 minus x squared equation. That's that one. And then this is my e equation. Going to look something like that. I'm going to do this strictly on my calculator. I'm doing nothing by hand, pretty much. All I'm thinking is that I want the area enclosed by these two regions. I just want area. So I'm just doing the integral from, I'm going to call this intersection A, and I'm going to call this intersection B. The integral from A to B of the top curve, which is y2 in this case, minus my bottom curve, which is going to be y1 in this case, dx, because this was my y1 and this was my y2. And I want to do top minus bottom. And I'm just adding them all up and doing dx slices. This is just an area problem. No revolving, no pies. Let's go ahead and find those intersection points. Second, calc, intersect, and I'm going to store it in A and in B. So I'm going to start with my left, go to the point, and press enter 3 times. And then hop out of here for a sec and store that x, because we're going to find the other intersection. Store that x in alpha A. Boom. Now let's graph again and find the other intersection. Boom. There we go. So let's hop out of there. And now this value, let's store it in B. Now this graph happened to do symmetry, and you could do some shortcuts for symmetry, but I'm just going to give you a general case of how you can always do this type of problem purely on your calculator, and you will be seeing this on your exam, so make sure you know how to use your calculator, because that's going to save you a whole lot of time. Anyway, you can't take these integrals by hand. We don't even know how to do them. We are going to math 9 fn int, and we are going from A, which was my smaller bound, to my top bound, which was B, and we were doing the top curve, which we had stored in y2, vars, pick y2, minus vars, this time pick y1, dx. X is the variable, enter. Let your calculator do all the work. That's it. Equals 4.277, because I need 3 decimal place accuracy, and that's my answer. That's going to be on your exam. Make sure you know how to do it. All right. There are just 2 small reflection questions that I would like you to do in the Pear Deck. And that's it for this lesson. Good luck on your exam. Bye.